Okay, folks, so we're going to look at proving some of our angle properties, and then we're going to do some just identifying where people can make mistakes in this kind of stuff. Okay, so all that stuff comes into play here. Now, there's two key assumptions that we have to run on before we can get into proving what our angle properties are. Now, we already know what they are, but we want to prove it, so some good rigor with deductive reasoning here. So the first thing we need to remember is that if I have two angles along a straight line like this, they have to add up to 180 degrees. You probably call that the straight line theorem or something in junior high. But we just say that they're supplementary angles and they have a sum of 180 degrees. Okay, so don't forget that. Now, the next one is called the corresponding angle postulate, which is not really a postulate. In math, the word postulate means it's kind of like a theorem, but it's so obvious that you don't have to prove it, right? But I'm going to make a note that you can prove this one. It's just that the proof is really very involved, okay? It's quite complicated. It's harder than we could do in this course, really. So we're just going to have to accept on faith that any pair of corresponding angles, like for example 2 and 6, would be the same, okay? As long as these lines are parallel. Now, you might see some folks will say, well, I can prove this and it's not that hard, and they'll do it and they'll make use of some of the other properties. But you need to use this to prove the other properties. So if you get involved with using one property A to prove property B and property B to prove property A, then that's circular reasoning. So we have to accept this one on faith. All right. So proof number one, our conjecture is that vertically opposite angles are equal. Okay, so we know that's true, but now we want to prove that it's true. So what we've done here is we've taken a transversal, but more importantly, we're just looking at these four angles up here. So we want to show, for instance, that angle 1 would be equal to angle 3, and that would prove it for us. Okay, so in order to do that, we're going to start off by saying angle 1 and angle 2 are along a straight line here. So angle 1 plus angle 2 is 180 degrees. That's our supplementary property. Okay, that's good. Then, by just taking that little equation we wrote and doing a quick subtraction of angle 2 from both sides, we get that. Okay, not much to that. That's our second statement. Third statement says that angle 2 and angle 3 over here are also supplementary, so they have to add up to 180 degrees. Okay, that makes sense. And then another quick subtraction, subtracting angle 2 from both sides, we get this equation. So now the important catch here is that we've noticed that angle 1 is equal to 180 degrees minus 2, and we've just shown that angle 3 is equal to 180 degrees minus angle 2. So if those two angles, 1 and 3, are equal to the same thing, they must be equal to each other. That's called transitivity, or the transitive property. Okay? So we've just shown that angle 1 equals angle 3. Quod erat demonstrandum. Okay, so there's the first one, vertically opposite angles. We've now turned our conjecture into a theorem. Next one, we want to prove that alternate interior angles are congruent. So our goal here, and you can always look to see where we're going to end up, we want to prove that angle 4 equals angle 6. So we want to show that this angle and this angle are the same. So how do we go about that? Let's follow the proof. It says angle 4 plus angle 3 equals 180 degrees. So we're saying that angle 4 plus angle 3 is 180. Those are supplementary. Yep, straight line. Okay. So then by subtraction, we take angle 3 and subtract from the right-hand side, and we get angle 4 is 180 minus angle 3. Pretty good. Now, they're saying that angle 3 equals angle 5 by correspondence. And remember, we had our corresponding angle postulate. So that means that angle 3 and angle 5 have to be equal. Okay, that's good. So if that's the case, now let's see the trick that we're going to play here. If that's the case, if angle 3 and angle 5 are the same thing, we can take that equation that we just had written and change the angle 3 to the angle 5 with a little substitution. Okay, so then this equation should have to be true. All right, so then the next thing we're going to do is we're going to say that angle 5 plus angle 6 has to add to 180 degrees. And that's a straight line, so that's okay. And then angle 6 will be 180 minus 5 by subtraction again. And then we have that angle 4 and angle 6 are both equal to the same equation. So they must be equal to each other, transitivity property. Next one. Prove that same side interior angles are supplementary. So we want to end up showing, in this case, that angle 4 plus angle 5 add up to 180 degrees. Okay, so that's what it means to be supplementary. So we start with angle 4 plus angle 3 equals 180, right, because they're along a straight line. Then we're going to say that angle 4 is just 180 subtract 3. Okay, that's just a rearrangement of the previous step. Now we're going to say that angle 3 and 5 are equal, and that's by corresponding angles. Okay, so 3 and 5 are the same. That's good. And then angle 4 will be equal to 180. We said it was minus angle 3, but now we can change the 3 to a 5 by substitution since we know that they are equal. Okay, and then angle 4 plus angle 5 will have to equal 180 degrees. Okay, because all we have to do is take the angle 5 over here and add it back to the other side, and we've got it. Okay, good. Next one, we want to prove that alternate exterior angles are congruent. So we want to end up showing here that angle 1 and angle 8, those alternate exterior angles, are the same. So we start by saying angle 1 equals angle 3 because they're vertically opposite. Right, and we've already proven that vertically opposite angles are true. Then we can say that angle 3 is equal to angle 8 by correspondence. Oh, okay, corresponding angles are the same. Oh, so then by transitivity, if 1 equals 3 and 8 equals 3, 1 equals 8. And that's all of them. Okay, the one thing we have to be careful about, or one thing we want to note, is that you should also be pretty handy at identifying errors in proofs like this. Okay, so here's a statement and a justification for a two-column proof. So we've got BFG equals 45 degrees. Okay, and I can see that here. That's a given. And then it says interior angles on the same side of a transversal are equal. So BFG equals FGD. I don't think so. They're saying that this angle and this angle have to be same. Are they supposed to be equal? No, they're supposed to be supplementary. So what does that mean? That means BFG, or FGD, would be equal to 180 minus BFG, okay? So be very careful about that stuff. Sometimes folks make mistakes. So we need to make two assumptions to prove all the properties that we had, those same two, straight line or supplementary, and the corresponding angle postulate. And then we are able to deductively prove the rest of them. So the rigor that we use here, or the detail, is important, and it's a good way for us to practice these two-column proofs because they're coming back at us again soon.